Hey, have you ever really looked at the world around you? I mean, it's just a giant puzzle, right? Made up of all these different shapes. But how do we actually measure them? Whether you're trying to build a fence for your yard or just paint a wall, it all comes down to two really simple ideas. Today, we're going to unlock the secrets of area and perimeter.
I mean, think about it for a sec. How much fence do you actually need for a garden? Or how much paint do you need to cover a wall? These aren't just abstract math questions from a textbook. These are real-world problems. And the solution? Well, it's all about understanding two simple but super powerful geometric concepts.
So what is the difference between them? It's actually really simple. Perimeter is the distance around a shape. Think of it like you're walking along the very edge of a field. Area, on the other hand, is the space inside that boundary. That's all the grass inside the fence. So one's the fence, the other's the field. Easy, right?
Okay, so where do we even begin with all this? Well, we start with the unsung hero of geometry, the triangle. Now, you might be wondering, why the triangle? Because pretty much every other shape with straight sides can be built from them. Seriously, it is the ultimate geometric building block.
Now, to figure out a triangle's area, you only need two little things. Its base, which can be any of its three sides, and its height. But here's the crucial part. The height isn't just another side. No, it's the straight line distance from the base all the way to the opposite corner, and it has to form a perfect right angle. That's the key.
And that brings us to this classic, super elegant formula. The area is just 1/2 of the base multiplied by the height. So why 1/2? Well, think about it. A triangle is basically a rectangle, or a parallelogram, that's been sliced perfectly in half. So it just makes sense that its area is exactly half of that, right?
Let's put this formula to the test with a quick example. Okay, say we have a triangle with a base of 10 centimeters and a height of 6. We just multiply those together, which gives us 60. Then slice that number in half, and bam, you've got your answer, an area of 30 square centimeters. It really is that straightforward. So, now that we've got triangles down, let's see what happens when we start sticking them together. And that brings us to the quadrilateral family. Yep, all the shapes that have 4 sides. I guarantee you'll recognize a few of these guys. Okay, check this out. On the left, a good old rectangle. On the right, a parallelogram, which, let's be honest, just looks like a rectangle that someone kind of pushed over. And that's the secret. Imagine you just sliced off that little triangle on one side and moved it over to the other. You've just turned it back into a rectangle. And that's why their area formulas are so similar. It's just base times height.
And the rest of the family kind of follows the same logic. For a rectangle, we know it's length times width. For a square, since all the sides are the same, it's even easier, just sides squared. The trapezium is the really interesting one. Since it has two different parallel sides, you just find their average and then multiply by the height. See? Each formula is just a little twist on that same core idea of measuring the space inside.
All right, we have totally handled shapes with straight lines. But what on earth happens when a shape has no straight sides at all? I mean, how do you measure something that's perfectly, endlessly round? You can't just measure a base, you know? There are no corners to work with. It's a completely different kind of puzzle. So, to solve it, we need a secret weapon, a single, kind of magical, constant number that unlocks all the secrets of the circle. And that number is, of course, pi. It doesn't matter how big or small the circle is, if you take the distance around it and divide it by the distance across it, you always get the same number, about 3.14. This constant, pi, is the magic key we've been looking for. And with pi, we get two beautifully simple formulas. For the circumference, which is just a circle's perimeter, it's 2 times pi times the radius, and for the area, it's pi times the radius squared. Just think about that for a second. If you just know the radius, that one single line from the center to the edge, you can figure out absolutely everything else about any circle in the universe. So, we've got our basic building blocks: triangles, quadrilaterals, circles. Now this is where it gets really fun. We're going to use everything we've learned to deconstruct the complex shapes we see out there in the real world. So let's take a look at this kite. At first glance, it seems kind of complicated, right? But look closer. It's not one weird shape at all. It's actually just 3 simple triangles stuck together. And that's the first step to solving any complex shape. You gotta find the simple ones hidden inside. Step 2 is just divide and conquer. We take our simple triangle area formula and apply it to each piece, one by one. The calculations tell us the top triangle is 173.2 square centimeters, the middle one is 240, and that little one at the bottom is 24. And what's the final step?
You guessed it, we just add them all up, which gives us a grand total area of 437.2 square centimeters. See, that's the power of this whole technique. We just solved a complicated-looking problem by breaking it down into super easy pieces. The philosopher Aristotle famously said, "The whole is greater than the sum of its parts." And yeah, he was talking about some pretty deep stuff, but it applies perfectly to geometry. By understanding the simple parts, we unlock the power to measure the entire complex whole.
So the real takeaway here is that geometry isn't just stuck in a textbook. It's everywhere. It's in the design of a building, the layout of a park, even the shape of a kite. So my question to you is this. Now that you know how to see the building blocks, what complex shapes in your world can you start to see in a completely new way?